In the second part of this problem, we need to start getting some information and doing some calculations so we can work out the height of the helicopter above the landing pad. The first thing we need to do though is to work with the triangle along the bottom, the base along the ground, so triangle ABO. And I've drawn that here, and I've drawn a little guide here what direction it's moving, what direction it's going. And we know that the observer walked from point A to B, and that was 500 metres. So we're after this length here, AO. And when we've got that length there, we can then use some right angle trig calculations and actually work out what the height here is. So let's do this first. So let's call this X. So we've got 65 here, opposite, adjacent, so we're going to use tan. So tan of 65 degrees equals opposite, which is X, over 500, which is the adjacent. So X equals 500 times tan of 65. So very quickly going to the calculator, so 500 times tan of 65, enter. So it's 1072 metres. So we'll just do it to the nearest metre. Okay, so X equals 1072 metres. Okay, so that's the first part of it. So we now know this length here. So from there we can start to look at our triangle. So let's draw a triangle. I'll do that very quickly. So very quickly I've drawn triangle AOT up to the top of the helicopter. Okay, and there's the landing pad. Now we know that this distance from here is 1072 metres. We know that the observer is looking up at 60 degrees. Okay, and now we want to find the height. So this is X, so just another right angle problem. So tan 60 degrees equals X in this case over 1072. X equals 1072 times tan of 60 degrees. So we'll just put that in the calculator and it'll give us the height. So 1072 times the tan of 60, enter, okay, equals 1857 metres. X equals 1857 metres. Okay, therefore helicopter is 1857 metres above